I welcome you all for this wonderful session about SOLIDWORKS Simulation. Myself Shamchandra, Application Engineer representing EGS Computers India Private Limited. These are the agenda we are going to be say in this session. So SOLIDWORKS Simulation. So why SOLIDWORKS Simulation? Okay, so what is the conventional processes? We will do a design, then we go for a prototype modeling, then we test the model, and once the result is not satisfactory, we will go for redesigning it and another prototype to final confirmation of the product requirement and safety process. In SOLIDWORKS simulation, the moment we design the product, we can go for simulation where we can check the product's capability and how much load it can withstand, whether the requirement has been met or not, so that the prototype cost will be cut down, so the overall cost of the product will be reduced and time to the market will also be in a very optimum value. Not only that, we can do lot of innovative and development studies by doing various analysis on this model, so that we will get more detailed understanding of the component performance. So SOLIDWORKS simulation has three design validation products: SOLIDWORKS simulation, which is about basically a structural based analysis, and SOLIDWORKS flow simulation, which we use for internal and external flows in an hydraulic valves or pneumatic valves and another various conditions, and SOLIDWORKS plastics, which used to simulate the mold plastic flow in a component of injection mold process. Now let's focus on SOLIDWORKS simulation. Okay, this is the product matrix of SOLIDWORKS simulation. In SOLIDWORKS simulation, we have a model, a standard, in which we can do a static analysis, which means we can run study so that we can get to know whether the component can withstand the load or not. And fatigue analysis is for how many cycles the same kind of load can be withstand, for how many cycles. And in motion, we have time based motion analysis. So let me explain this with an example. If an automatic packing industry is there, time based motion analysis can be used there by simulating the motion of the conveyor belts and the motion of an object to which the station is going to be stopped, or in which station it going to be loaded. Not only that, we also calculate the kinematics. For example, the RPM needed for the conveyor roller to rotate to get into the right position of the package. And trend tracker is nothing but we can do the various kind of simulation on the same interface, like changing the mass, material property on the same interface, so that we don't need to change it in the model and we don't need to come back to the simulation interface for each and every time. On top of SOLIDWORKS simulation standard, we have a professional, in which we can do frequency analysis, so we can find a component's resonant frequency and whether it's in optimum value or not. And optimization is about automatically calculating the required dimensions with the goal based inputs we have given. And drop test is like the sudden impact of a component by dropping in particular height on a particular surface. Thermal analysis we can do, like what is the temperature distributions, what is the thermal stress developed due to the temperature variations. And buckling analysis we can do for structural components where a slenderness ratio is there. And pressure vessel is dedicated to a pressure vessel where we can do lot of dedicated analysis. 2D simplification and submodeling or simplification tools, where we can simplify very complex model to an simplified one, so that we can do the simulation in a very faster manner. And material web portal, in web portal we have lots of material library which we can download it once we need. And event based motion analysis, it is similar to time based motion analysis, but it has an we can give an feedback system. For example, let me take that same example of automatic packing industry. What I can do in event based motion analysis is I can see, okay, this moment the package has been reached to this station. So the moment it reached this station, the another component or another packing component need to be moved. What we do in time based motion analysis is the shaft should rotate for this much of time, and this component should move from 0th second delay. But in event based motion, we will give as once the component reached station A, then the component should go for station B after only it reached station A, like that. And top of professional, we have a premium where we can do nonlinear statics, linear dynamics, and nonlinear dynamics. So let us see what we can do on this steering bracket of an group and rally car. So these are the possible analysis we can do on the steering bracket. Let's see. First, let us see the static analysis which can be done on this bracket. Let me show you in the SOLIDWORKS interface. So this is the entire car steering model, and this is the exploded view of the model. Now let's take this bracket alone for the simulation. This is the graphic window of the SOLIDWORKS, and if we want to go for simulation, we need to go to add-in, and we supposed to check SOLIDWORKS simulation win title and whatever. Like for example, we need to go for a SOLIDWORKS plastics or SOLIDWORKS flow simulation. We need to check that options here. Now this is the interface of SOLIDWORKS simulation. SOLIDWORKS simulation has a very simple 5-step process: assigning the material, fixtures, loads, meshing the model, and viewing the result. Okay, so we have get the model in this interface. Now let's give that material property. So we assigned alloy steel for this component, and this material is available in SOLIDWORKS material database itself, and all these properties also. So the properties which are in red mark are compulsory data need to run the analysis, and the material property which are in blue are optional or not required for this particular analysis. Now we have chosen alloy steel. Then fixing the component, I have fixed in the 3 holes. Now external load, so the fixtures and the external loads comes under boundary conditions. So external force, I have given this location. Now meshing the model, so now we have just meshed the model. Go for run the analysis. So we get the maximum stress and minimum stress here. Not only that, we can also get the displacement value and the factor of safety, and we can easily document this analysis report by just clicking this report option. So we will get an well structured document file of the results we have done and the what result values we have got, and this document format is customizable. So what we have seen in static analysis is how we need to see the factor of safety and finding the peak and overall stresses on the model and calculating the strength of the part. Now let's see fatigue analysis. Okay, we need to give we need to open a new study through this option. Like we have a list of options here, whatever we required. So just choose fatigue. Now just add an event like the percentage of load cycle and from which study you need to import, because fatigue is an post process analysis, so we can't just straight away go for fatigue analysis. We need to do some static kind of analysis. So we have chosen here the static analysis and fully reversed cycle. So let's see what is the damage percentage of this component. So this is the damage percentage and this is the life cycle of the product. And the most important thing in fatigue analysis is we have an inbuilt database about SN curve. We don't need to get it from externally. We have an inbuilt data. So what we have come across in fatigue analysis is calculating the life cycle and what is the mean time between failures, finding the replacement parts in the assemblies. Frequency. Now let's see the frequency model. In frequency model, just copy the material property from the previous study from like this option, just drag and drop, then apply the fixture to this model. Now this is the frequency model. So this is the various frequency. We can also animate this frequency model. So we can find the mass participation of this model, so whether it's in the required condition or not. So in frequency analysis we can calculate the resonant frequency, natural frequency, associated mode shapes and mass participation factors. Optimization. So optimization is a best tool for designing, which we need to optimize it in a way of weight or in the stress levels. So let's see, in optimization I have just in the variables given thickness values. So I have just chosen the thickness of the component. Then I have given a constraint like stress and frequency, and we can include whatever constraints we required. And this entire process is goal based process. So we need to give a goal like mass or stress level which we need to minimize or maximize, and this optimization will automatically run possible iterations so that we will get the optimum value. So the current model which was designed in this data conditions, now the optimization run 4 possible iterations. Among that, this one is among the 3 iterations we got an optimum value. So this is the optimum value. So the inbuilt design we have is the initial value we have is 353.337 grams, but in the optimized value we have 221.035 grams. So what we have come across in optimization is we can optimize weight, stress, displacement and factor of safeties, and we can also do what if scenario, like what if I reduce the thickness to this much value, or what if I increase the diameter of a component. Summary. So Let's see what have we come across of in SOLIDWORKS simulation. In SOLIDWORKS simulation, we can easily view the results, and we can see a detailed view of the component products. Not only that, we can also get a very detailed document of the component, which we have done for the simulation. And it's a goal-based optimizations available, so that we don't need to redesign the component at each time we get an unsatisfactory answer. The optimization will do that for us. Thank you all for this wonderful session. Kindly contact us for any further clarification or requirements. Thank you, gentlemen and ladies.